So today we're looking at hyperbolas, so the last of the conic sections that we studied in this unit. So when we have conic sections, what we're looking at is the absolute value of the difference between the distances from points to foci. So again, I would remind you that the important and the key word here is difference, meaning that we're looking at some kind of subtraction for our equation. So that's kind of the easiest way to identify what type of conic section it is that we're looking at. So hyperbolas can take two different forms. We can have a horizontal hyperbola, meaning that the x value is positive, the y value is negative, and the axis of symmetry that hyperbola sits on is going to be horizontal, so left and right. And then a vertical hyperbola, the y value is going to be positive, the x value is going to be negative, and the axis of symmetry where that's formed is going to be forcing that hyperbola to move up and down, or open up and down on both sides. So here's a couple of examples. So this first one in blue would be a horizontal hyperbola. So it's opening to the right and to the left. This one would be our example of our vertical hyperbola. Now again, from those equations, we have these distances that we move towards these vertices on either side of the hyperbola, and we move away from our center point. So every hyperbola has a center point. It's actually where these lines are intersecting here in the middle. Okay, and so our central rectangle comes from our A and B value. So whatever is with your x squared value is going to move you horizontally along the axis. Whatever is your with your y value is going to move you vertically along that axis. And these sides of that central rectangle are your asymptotes. And so that's what causes the sides of those hyperbolas to move away and kind of spread out. So they almost look like parabolas in some sense of what we're looking at graphically there. So again, central rectangle, we construct it using the A and B, so left and right from the center point, and then up and down from the center point, which is H and K in your equation, and your diagonals of the rectangle are asymptotes of the hyperbola. So to find your center and vertices of the hyperbola, we've got to do some completing the square. So for these, again, what we want to think about is I need to group together x values and y values so that I can complete the square there. And then I'm going to take and move that constant to the other side of the equation. For this 4x squared plus 16x squared, we need to factor out the 4 from both of those terms. And then we divide by 2. So 4 divided by 2 is 2. 2 squared is 4. So we completed the square for the x. We have to be really careful here because we do need to factor out the 1 before we complete the square for the y values. So that's going to become 2y. Half of 2 is 1. 1 squared is 1. And this equation is still equal to 21. Now again, we did change the left side of the equation, so I have to change the right side. So 4 times 4 means I'm adding 16 to the right side. Negative 1 times positive 1 means we should also be adding a negative 1 there to the right side. So then the next step is to keep simplifying this equation so I can get into that form so I can see what's happening. So 4 times x plus 2 quantity squared minus y minus 1 quantity squared is equal to, let's see, that would be 21 plus 16 is 37. 37 minus 1 is 36. So our equation for our hyperbola should be equal to 1. So whatever is on the other side of the equal sign, that's what I have to divide by so that I can make that be equal to 1. So divide everything by 36 so that we keep our equations nice and balanced. Now I'm looking at the fraction 4 over 36. So the fraction 4 over 36 is going to be 1 over 9. So x plus 2 quantity squared over 9 minus 1 minus y minus 1 quantity squared over 36, there's nothing to simplify there, is equal to 1. So your center for this one is going to be at negative 2, 1. So we can start here with a picture at negative 2, 1. We know that this is going to be a horizontal hyperbola because the x value is positive, so that means that I'm moving 3 units away because we would take the square root of 9 to get to the 2 vertices. So negative 2 plus 3 is going to take me to positive 1, and then it would still be on the same y as the original. Negative 2 minus 3 is going to take me to negative 5, 1, and then that side would open in that direction. So for our second example here, 16y squared minus 9x squared plus 72x minus 32y minus 272. So again, what we're thinking about is I've got to start to group some terms together. And I'm going to put the 16 out in the front because it's positive. The 9 currently is negative. You do have to be careful. That doesn't always stay true. It depends on what you have to divide by as your last step. And then we're going to say that it's going to be equal to 272 when I move that to the other side. So again, we start by factoring out 16. So we have y squared plus 2y. Let's go ahead and complete the square. That's going to be 1. Factor out the 9 here. 9x squared plus 8x. And then go ahead and complete the square. That's 4. 4 squared is going to give me 16, and then that's going to be equal to 272. So again, we're going to have to add something to both sides of this equation in order to keep this balanced. So 16 times 1 is 16, negative 9 times 16 is 144, but that's a negative, so I need to make sure that we keep that and subtract. So 16 y plus 1 quantity squared minus 9 x plus 4 quantity squared is going to be equal to 272 plus 16 minus 144, which is 144. Again, I need this to be equal to 1, so I have to divide by 144. All of that gets divided by 144. So our final equation is going to be y plus 1 quantity squared over 9 minus x plus 4 quantity squared over 16 is equal to 1. So we have a vertical hyperbola. We know that the center, need to be careful, the center is actually going to be at negative 4 because that's the value that comes from our x in this equation. So negative 4, negative 1. We're going to be moving up 3 units to get to the vertex. So it's going to be opening this direction and this direction. So negative 4 is going to share the x value because the x value is not changing. Negative 1 plus 3 is going to put that vertex at 2. For the one down here, again, negative 4, and then I'm moving 3 to the other direction, so that's going to be negative 4. So that's everything for hyperbolas. If you have questions, you can send me some emails or comments, and we can talk about those further.